In this video today, we are going to revise the topic of heat energy and a little bit on light energy. Hi, I'm Mr. Long and I'm your science teacher today. Alright, in this video, we will be using the heat energy mastery worksheet questions as well as the P4s 2017 questions. Now let's take a look at question 13. So remember, whenever you try to understand a question, we need to look at what is the concept tested. And very often we are playing the role of a detective and trying to figure out what that is. Canaan conducted an experiment as shown below. Right, there's a container there. And, okay, two containers. Now Canaan poured 200 ml of water at 80 degrees Celsius into each of the containers, which were similar in size. Now, when we look at this, let's take a look at the variables. Now, I hope that you have watched the other video on variables, so these terms are more familiar. If you have not, please look at the answering open-ended question video. Now, constant variables, measured variables or results, and change variable. So, 200 ml of water at this temperature were poured into each of the containers. So, what does this tell you? This tells you that the amount of water is the same. It also tells you that the starting temperature in both of the water in both containers are also the same. Now, what else? When we look at the idea that the containers were similar in size, we also know that what was kept the same, constant variables, were also the size of the containers. What else? When we read on, we find out that the two containers were placed in the refrigerator at the same time. That means that the location of the containers were the same at the same time. Location of the containers were the same, the refrigerator. Next, we also look at the time of placing the containers into the refrigerator were also the same. You see, at the same time. When I read on, he measured the temperature of the water in the two containers at 5 minutes interval. That tells me that that interval was kept the same. That means that at 0 minutes, it was at 80 degrees Celsius for both containers of water. After 5 minutes, this Canaan recorded the temperature of the water in both of these. After 10 minutes, recorded the temperature of the water in both containers. After another 5 minutes, which is 15 minutes later, he recorded the temperature of the water in both. So, when we look at the results were recorded. That results will be what we look at here, the temperature of the water. And that is a variable that we measure, or that Canaan measured, which is the temperature of water. So what is different? What has changed? Because in this question so far, there's no mention of Canaan's aim. Why did he do this experiment? So we got to figure that out. And when we look at this, we know that the change variable is the different containers. And if the two containers were made of the same material, then this drop in temperature should be the same. However, it is not. The two containers must therefore be made of different materials. Now, then what is the concept being tested here? The concept actually is the heat conductivity of materials. That means that one of them must be a better conductor of heat. The other one is a poorer conductor of heat. So let's try to answer this question. Remember, always go back to the concept. It's about heat conductivity of materials. So why is there a change in the temperature in both containers? So let's observe the information given in the table. In both containers, the temperature were showing a decreasing trend. Decreasing, becoming smaller and smaller. Therefore, and this is happening in both containers. So we can answer very simply, the temperature of the water in both containers are decreasing. And we're asking for why, right? Why? Why is a reasoning. So the change in temperature is the first part. I explained it here. They are both decreasing. Second part, why? Explain this change. Heat is lost by the hot water to the surroundings, or heat is lost by the hot water to the refrigerator. And the concept here is also about rate of heat lost. So container A, remember, is made of therefore we can infer that container A must be made of a better conductor of heat than container B. So heat lost by the water in A to the surrounding must have been more than heat lost by the water in B in the same amount of time. So the temperature of the water in A is lower than the temperature of water in B after the same amount of time. This is meant to help you understand what's happening in this experiment so far. Now, if Kenan wanted to bring some hot coffee to work, which container should he use to ensure that the coffee remain hot for a longer period of time? Now, I've asked my students to remember this, that the idea of poor conductors of heat keep hot things hot and cold things cold. Right? Remember this, and this answer will be easier for you. This kind of question will be simple. So, clearly, since he wants to keep his hot coffee hot, we use container B, because container B is the poorer conductor of heat, right? A is a better conductor of heat, so B is a poorer conductor of heat. So how does it work? Explain the answer. B is a poorer conductor of heat, so it will slow down the rate of heat lost by the hot coffee to the surroundings. Let's go and look at question 12. Now, question 12 here, the question asks us which material would cause a jar to lose heat most quickly. Words like this tells us clearly the concept again here is about heat conductivity of materials. Let's look at this. Poor conductors of heat can also be called insulators of heat. However, please do not do so. This will not be used actually much at the primary school level, because insulators are usually reserved as a word to describe insulators of electricity. So the primary school level use words such as poor conductors of heat or good conductors of heat. Do not use insulators of heat. Alright, do not. So Sam carried out an experiment on poor conductors of heat. She used 5 similar size jars, and each one filled each one with the same amount of water. The initial temperature of the water in all the jars was 60 degrees Celsius. She wrapped each one in a different kind of material. So now we know that the initial temperature was at 60 degrees Celsius, and this was a table that recorded all the information here. Now, if the initial temperature was 60, then what happened after 10 minutes? You notice that this one, for the material, for jar A, I call it jar A, although this is actually material A. I'll call it jar A. For jar A, the water inside, the temperature of the water inside dropped from 60, all the way to 40 degrees Celsius. The temperature drop is the most here compared to all the rest. Therefore, this can tell me that A is the best conductor of heat, and the best conductor of heat allows heat to pass through most easily. Now, look at jar E, which has a material E wrapped around it. The temperature dropped the least from 60 degrees Celsius, dropped only by 5 degrees Celsius to 55 degrees Celsius. This means that the temperature drop is the least, therefore E is the poorest conductor of heat. And that means that the answer to this, which material will cause the jar to lose heat most quickly, it must be material A. And give a reason, the temperature drop is the most compared to the rest. That is the evidence from the table. And the reasoning which means A is the best conductor of heat that allowed heat to pass through most easily. Now, having this information there already, let's try to answer B. Sam plans to take some cold drinks to a picnic. Remember? Which kind of material would help him to keep his cold drinks cold? Yes, poor conductors of heat will keep hot things hot and cold things cold. So which material should she use for a box to place the drinks in so they remain cold during a picnic? Well, look for the poor conductor of heat, look for E. And reason is very simple. It is the poorest conductor of heat. So 1 mark for the concept, but it's 2 marks here, right? So explain it. It will slow down the heat gain by the cold drinks from the surroundings the most. 1 mark for the reasoning or the explanation. Question 11. The diagram below shows water boiling in a beaker. So there's a thermometer here, and this is a zoom in part of the thermometer. It shows 100 degrees Celsius. And so Kevin took 10 minutes to boil the water in the above experiment. There are 3 candles here. What if he would add 2 more candles? How would this affect the time taken to boil the water? Now the idea here is, well, if you supply more heat, then things being heated will gain more heat in the same amount of time. Common sense, isn't it? So therefore, the idea here is time to boil water will be less. Because we're asked to find out how will it affect the time taken. It will be less time. Now please take note, time cannot be faster nor slower. You cannot make time move faster. But Now explain your answer in part A. This will refer back to this idea that we talk about here. So as there is more heat, the water gain more heat in the same amount of time, so the water will boil in a shorter amount of time. Let's look at question 10. Which of the following actions may cause the wooden stopper of an empty bottle to pop out? Now, what is the concept in the question here? We look at the clues. Wooden stopper of an empty bottle to pop out. That means that the concept here is about effects of heat gain and heat loss. Matter expanding when it gains heat. Matter contracts when it loses heat. I highlight this in yellow, meaning that this is the focus here. Matter expands when it gains heat. So as it gains heat, what happens is that the bottle gains heat from the heat source first. And then when the bottle is hot, the hot bottle will transfer the heat to the air in the hot bottle. And this hot air will expand when it gains heat. It will push against all the sides. It cannot push. You try to push a glass, but the glass will not budge. So you also push against the wooden stopper. And the wooden stopper can be pushed out if the pushing force is hard enough. Alright, and that's why the wooden stopper will pop out. Now let's go on to another question. Now this is an extra question that we can try. The diagram below shows an iron ball and a metal ring. Now provide two suggestions with reasons on how we can get the iron ball through the metal ring. Remember the questions here, they want two things, suggestions and reasons. Alright, so be very careful how you answer this. Now, whenever you see iron ball and metal ring, it's very clearly this must be about metal gaining heat, expanding, metal losing heat and contracting. Now, imagine if the iron ball is smaller, it can definitely go through the ring so much more easily. So how can I make the ball contract, right? How? Similarly, if the metal ring were to be larger, it can definitely let the iron ball go through more easily. So the idea now is to make the iron ball go through the ring easily. How can I make the ring expand, be larger? And the concept here, as we talked about before, is about metal expanding when it gains heat and metal contracting when it loses heat. Let's talk about the how. Place the iron ball in the freezer for 24 hours. That is the suggestion. And then I provide a reason. Metal contracts when it loses heat. Next one, second suggestion. There are two suggestions, right? Put the metal ring above a flame. And the reasoning, metal expands when it gains heat. Let's try this other question. Now, Mabel noticed there were gaps on the MRT train tracks. She was told that having gaps on the train tracks in countries when the weather is hot is very important. Now, what clues? Weather is hot. This will tell you the topic is not about lights or about matter or about animals. It is about heat energy. Alright, so the concept here again is about metal expanding when it gains heat. So what happened under a hot day? What happened to these metal train tracks? Well, it will gain heat from the hot sun and it will expand. But what if the train tracks expand and there are no gaps, like as shown in the picture? Why are there no gaps? So for example, what it expands like this, right? If you push in all direction, it will expand, become larger. If there are no gaps, this is what will happen. And this happens in real life, where the design of these train tracks, not in Singapore, alright? This part here actually warped, it buckled. Imagine a train were to go over this track and this part, the train could easily be derailed because this part now is no longer straight. Right, having gaps in the parts of the train tracks will allow the train tracks to expand without buckling or warping. Now let's go on to something on light energy. Lisa used a light sensor connected to a data logger to measure the amount of light that was able to pass through different materials. So understand the picture, there's a light source, material tested here, there's a covered box to prevent light from entering, there's a light sensor connected to the data logger, and there's result presented in the graph. The amount of light is represented here, and here will be the different type of materials. So what will be the aim of the experiment? So firstly, the first part, let's understand this. The aim is, Lisa wants to find out if the amount of light that passes through different materials, what would it be? Alright, and what's the change variable here? What was being changed? Well, the materials were all different. That is the change variable. For material A, there was no bar here, means no light could pass through. For material B, some light could pass through. Material C, a lot of light could pass through. Material C, some light could pass through. Now, then what is a measured variable? Clearly, that will be the amount of light. that was what is being measured. That's why you could plot this graph. Now, which material is most suitable to make a clear glass window? Explain your answer. 2 parts to this. The concept tested here is whether different materials allow different amount of light to pass through. Clearly, alright, material C, this one, is the most suitable. But no marks for this. You got to explain why. So based on the graph provided, we know that C allows the most amount of light to pass through. Let's revise lights with another question. This one is on shadows. Now Lisa shone a torch at object K to form a shadow. Now how are shadows formed? They are formed when the light is blocked. So when this object blocks light, it casts the shadow of its shape. Now provide 2 suggestions that will make the shadow of object K smaller. So let's try to recall what we did during our shadow puppet project. Now, remember the concept here is size of shadows can be changed, but how do we change the size of shadows? If you move the torch further from the screen backwards, like this, backwards, then the size of the shadow will decrease. Another way is move the torch nearer to the object, then the size of the shadow will increase. What if I were to move the object instead? I move the object nearer to the screen, that will decrease the size of the shadow. Sorry, the word shadow is missing. And moving the object further from the screen increases the size of the shadow. Okay, I can also move the screen further back or nearer to the object. So there are 2 answers here. Moving the torch further from the screen decreases the size of the shadow. Moving the object K nearer to the screen decreases the size of the shadow.